if I start really from the reason, the purpose why we are interested in this, that the discussion in today's society is very threat focused, so that we're talking about climate change and resource depletion. Now it's the pandemic time, so there are of course a lot of crises that are threatening humankind, but it's also at the same time that we have perhaps the best tools ever at our use then to combat these challenges and turn these things into things that with humankind can thrive. So science and technology can provide hope during these types of times, but it's also something that we need to choose to support now and really invest into that area. And VTT exists for this sole purpose. Our focus is on finding solutions to these grand challenges through science and technology. The impact that we create comes from our work in science and technology, but it only acquires the value and the impact when a company applies it in their products and services. It can be also, of course, a part of society, that kind of like public authorities that utilize these technologies. And in everything that we do, we want to be doing things that really go a little bit beyond the obvious, so that we apply science in a new way, or we can find a solution to something which previously has been really difficult. And when you're talking about beyond the obvious, synthetic biology is smack in the middle of that definition. The fact that we can now start utilizing modern understanding about biology and biotechnology and these types of things, but also how we can apply digital technologies in novel ways. So it's also kind of like things like robots or deep learning. In the future, it will be quantum technologies, quantum computing through quantum biology that we can apply there. And we can actually modify these organisms in a way that they can produce something that has desired properties. We can utilize it then to really bring solutions to market that were impossible in the future. I think that that's astonishing, but it's also very necessary then if we think about the challenges that we then face in creating renewable materials, creating solutions that are climate friendly and promote all the right things. We also kind of like have seen that how fast this field has been developing in the past years, and one example of this is of course like the Millennium Technology Prize in 2021 that was awarded by the Finnish president to Subramaniam and Kleinerman for their work on gene sequencing. That has been one of the enabling technologies there that has made it also possible to make such leaps forward in synthetic biology. Now, from VTT's point of view, this of course comes then to the research that we are doing. That our job is to help in a way speed up and scale up the impact of this. So through the research that we're doing, through the people that we have, through the infrastructure, research and technology infrastructure that we have, we can help companies then utilize this knowledge that there exists, and without having to invest too much in the beginning, help start learning about these technologies, but also then that VTT can help then speed up the time to market from idea to innovation, but also then that we can scale up from laboratory scale then to the real factory scale, so that it can become commercial and really be both a commercial success, but also then bring these things to fruition. And this, of course, all the work that we do, nothing happens alone. So that nothing happens by only of course by our people. That this is a very collaborative field. It's very much happening in networks or ecosystems, and like in nature, it is very important that the ecosystems are as diverse as possible, so that we can bring different type of skill sets to work together, but also then that we then share the same goal, that we are working towards the same purpose, but then applying the different skill sets, and research organizations can have a huge impact also by facilitating this and making it possible then for large and small companies, universities, NGOs, whomever, to be working together and creating then those kinds of thriving ecosystems. And we are, of course, very involved in a lot of EU activities and active in the networks that exist in the synthetic biology area there. But as a whole, for VTT, synthetic biology is one of these areas where we believe that we will be creating absolutely gigantic impact for the good. It is one of these technologies that are breakthrough technologies. Some of the digital technologies are perhaps a bit better known in the general public's eye, but I think that we will know that how much good will be created through synthetic biology and investing into research and innovation work there.
Thank you, Antti, for the inspiring start. Next, we will hear from the Synbio Powerhouse co-creation manager, Tuula, please.
Welcome also on my behalf to this annual Synbio Powerhouse event. The more active promotion and development of Synbio Powerhouse was started about 3 years ago. So this is a kind of anniversary event, 3 years of Synbio Powerhouse. The goals of Synbio Powerhouse is to increase and accelerate the use of synthetic biology, advanced biotechnology in Finland and beyond. In these 3 first years, we have developed services that support the pathway from research to business. And especially we have been focusing how to encourage people to innovate and then help the innovator teams to turn the idea into product. And the other way we have supported is that we have been made it easy to access to ecosystem. And one of the goals has been that we co-create joint projects, and that has been really interesting and successful. Once again, welcome to our event, enjoy the program and innovate.
Our next speaker is the founder of Synbio Powerhouse and one of the world's foremost synthetic biology scientists, Professor Merja Penttilä.
Welcome everybody on my behalf as well. We are living exciting times because sciences are developing so rapidly, and it is no doubt that their integration, the interdisciplinarity, would bring great innovation potential and disruptive added value. On the other hand, we are living challenging times. As we all know, we need to combat climate change and to find ways to make a transition from fossil oil to sustainable solutions, both from the raw material point of view and the product point of view, to make the green transition in manufacturing possible. We believe that biotechnology should have and will have much more to offer for our future. Envisioning that we can use the synthesis power of living systems, such as microbes, in closed industrial production plants to manufacture basically everything we make today from fossil oil sounds like a radical thought. And the technology is in many ways radically different to all the other manufacturing technologies we have. This is why it may also be difficult to understand for those not in the field what all biotechnology could offer. One may get lost with all the gene acronyms, the gene name acronyms, and on the other hand, it is its enabling nature may not be as clear that one can produce products for various applications for fuels, pharma, materials, chemical industry, and so on, and that this can be done basically just engineering the code, the DNA, that then dictates what the cells can produce. Biotechnology has many benefits. One of them, and an important one, is that it follows intrinsically the rules of circular bioeconomy. Various complex raw materials and waste fractions can be used as feedstock for the microbes, and the products and process streams are recyclable and reusable. With the new tools of synthetic biology, we can make strain engineering much more rapid and predictable, and aim to make biology much more engineerable, and thus overcome the fact that biology is complex. We are actually on our way to biointelligent manufacturing, which is expected to become more and more important after 2030. This is how we see it at VTT. We can utilize the vast information of genomes and the biological functionalities, and in particular with the use of AI, machine learning tools, to make sense out of this information and pick up the best genes, for instance, for our purpose. A third pillar here on the left is the concepts of circular bioeconomy. We can then use this information to design production organisms through the so-called design, build, test, learn cycle of synthetic biology to obtain, in an iterative manner, superior strains for the real manufacturing process. We aim for a large number of examples where biotechnology can deliver sustainable solutions and processes that can be automatically controlled. We aim to fulfill the promise that we can demonstrate a large product range, even new to nature chemicals and materials, and design the bioprocesses to be carbon neutral. We aim for AI-assisted cell and process design and autonomous process operations. Finland has been already very early in the 80s, one could say, applying gene technology in industrial biotechnology. For instance, in engineering brewer's yeast to avoid formation of buttery flavor in lager beer, or in understanding how the amazing atomic level structure of wood hydrolyzing enzymes, cellulases, aid in biomass decomposition. This seminar is focusing on examples more of today's biotechnology and synthetic biology in Finland, both at the industry and in the research labs. This way we hope to increase the understanding of biotechnology and synthetic biology and get you all inspired of their potential and importance for the future.
Thank you so much, Merja. Aligned with the bioeconomy theme and cross-disciplinary collaboration, our next speaker is Professor Orlando Rojas, who is the Scientific Director of the Bioproducts Institute at the University of British Columbia. And here at Aalto University, he's the Principal Investigator of the Finceres flagship program. Orlando, what inspires you in this time as new collaboration and multidisciplinary action is required to mitigate the climate crisis and the resource deficiency?
So my thinking is that while the challenges associated to our energy and material needs have become global, most of the solutions are taking place in a more granular manner, that is locally. For instance, to the space and geography, we could perhaps add time, since the sense of urgency, for instance, with respect to climate change, is different depending on the location where we live. So science-based efforts that are being deployed involve quite numerous cross-cutting disciplines across the globe. And this includes those that relate to environmental sciences, chemical, physical, biological, social, and economic aspects. So divergence and convergence of the science is not an oxymoron. Now, more than ever, we need a specialization, and at the same time, the boundaries between disciplines should become more blurred, given also the tendency that we see nowadays in university systems and research centers to work on project-based models. So this interaction between researchers in an ecosystem really should lead to better learning and innovation. And in that sense, institutions around the world need to work together and wrap their heads around real-world problems. And this, for instance, requires students and researchers from different areas to work together across the globe, given that in different places in the world, the challenges are tackled in different manners, and perhaps there are many complementarities. So this is very important and calls for an action that should be global rather than local.
How do you see the opportunities for the forest industry to valorize some of the side stream sugars using biotechnology?
So my thinking here is that sugar streams produced from fiber processing are really currently at least underutilized. And here the power of biotechnology cannot be underestimated. I have learned, for instance, recently about the hybridization of typical pulp mills that not only produce wood pulp, but also are able to use residual sugars as a culture medium with microorganisms. An example could be, for instance, the production of bacterial cellulose. In the same manner, we can say similarly about efforts to use fermentation processes to synthesize polymers. And in this sense, one of the main attractive elements is here the possibility to produce molecules, oligomeric or polymeric compounds that are more uniform in their profiles. In such a way, we need to use feedstocks that can come from streams, from production lines, or from the end of life of recovered materials. And again, the possibilities here are enormous. And this really provides us a beautiful example of the regenerative nature of lignocellulose resources, which are not only sustainable and renewable, but can be inserted in a truly circular ecosystem.
Last, I would like to ask how the power of biocatalysis is in fact present at the Bioproducts Institute currently.
I can speak about our own efforts in the Bioproducts Institute here at the University of British Columbia. So one of the 5 pillars that we have in the Bioproducts Institute is biocatalytic transformation and engineering. And that signals the importance of this area in the context of the lignocellulose processing. The theme encompasses the biosynthesis and biological degradation of biomass, as well as the engineering of related processes, for example, to extract and valorize different biomass components. In this sense, we're carrying out fundamental research to understand how genes and their products function in the context of complex biological systems and synthesis or assemblies, or also in the degradation of biomass. So in this area, applied research is being deployed to look into protein engineering and synthetic biology to design biocrops and biocatalysts. The applications here, for instance, include the development of new biocatalytic routes to valorize biomass, or, for instance, to reduce the energy requirements in material production, or the functionalization of biomass by novel routes used in biology, and with an impact, of course, in materials manufacturing.